Hi, in this short video we are going to look at how to find the derivative of y is equal to the natural log of x, and we know that this function is only defined for values of x which are greater than 0. I should be able to write this in exponential form, and then I'll make use of the idea that d dx of e to the x is equal to e to the x to then deduce the derivative of y is equal to the natural log of x. So I'm going to go ahead and do that and say that y is equal to the natural log of x. Writing this in exponential form, it means that e to the y is equal to x. I'm going to call that equation 1. As I've said before, we know that d dx of e to the x is going to be e to the x. Now similarly, if I were to find the rate of change of y, of x with respect to y, it means I'm going to get this quotient here, d dx of y is going to be equal to e to the y. But remember, I'm trying to measure the rate of change of y with respect to x. So in other words, I'm looking for dy by dx. This is going to be equal to 1 over dx dy. But we've just found out that dx dy is equal to e to the y, so that is going to be over 1 over e to the y. From equation 1, we know that x is equal to e to the y, so therefore this is equal to 1 over x. So what we've managed to show is that dy by dx is equal to d dx of the natural log of x, and it's going to be equal to 1 over x. Now let's look at an example here. Let me call this example A. Let's suppose that y is now equal to the natural log of, say, 2x squared plus 3x, and we are looking to find what dy by dx is equal to. Well, the idea is to reduce this to a basic function y is equal to natural log of x. So I'm going to make use of a substitution and say let u is equal to 2x squared plus 3x, and then it follows therefore that y is going to be the natural log of u. Now dy by du is going to be equal to 1 over u, which is the derivative of the natural log of u, which we've just found, and I'm going to make use of the chain rule and work out what du dx is going to be equal to. So this one is going to be 4x plus 3. Now dy by dx is going to be equal to dy by du multiplied by du dx. So dy by dx of this current function that we're looking at is going to be dy du. It's 1 over u multiplied by du dx, which is 4x plus 3. But u is this term here, 2x squared plus 3x, so it'll be 4x plus 3 divided by u, which is 2x squared plus 3x. So let's look for a general way of differentiating this function. It follows that d dx of the natural log of f of x is going to be equal to the derivative of f of x divided by f of x. In the final example, we want to find the derivative of y is equal to the natural log of 5x plus 3. I'm going to give you an opportunity to pause the video at this point so that you can attempt the question on your own, and then you can compare your solution against mine. Welcome back. I hope you had some success. Well, let's dive into it. We are going to proceed in the same manner and say let u be equal to 5x plus 3, and if we do that, it follows that y will be equal to the natural log of u. So dy by du is going to be equal to 1 over u, and so similarly du dx is going to be equal to 5. Now dy by dx is going to be equal to dy by du multiplied by du dx. In this case, dy du is 1 over u multiplied by du dx, which is equal to 5 over 1. So we have 5 over u. But the derivative is a function of x and not u, and u is equal to 5x plus 3. So it'll be dy dx is going to be equal to 5 divided by u, which is 5x plus 3. And this is in keeping with the definition that we just derived, whereby we said it's the derivative of f of x, which is this in this case. So the derivative of that is the numerator of the quotient, and the denominator is f of x itself. Cheers.